So in 4.1 we talk about linear functions. So it's a slightly different emphasis than when we talked about equations of lines before. You know, a line's a geometric thing and there are many, many equations for lines, but a linear function is a function whose graph is a line. So those are functions of the form f of x equals some constant times x plus another constant. Or functions that could be simplified to that. So, for instance, f of x equals 1 plus 5 times x minus a half is a linear function because it could be expressed in that form if I distributed the 5 and collected up like terms. It's 5x, what's 1 minus 5 halves minus 3 halves? So that's a linear function. So they're functions whose graphs are lines. Linear functions describe things that increase or decrease as x increases at a constant rate. Because along the graph of a linear function, every 1 unit increase in x causes f of x to increase or decrease by the same amount. That's m. So linear functions f are increasing when m is positive, where that's some handwriting. They're decreasing when m is negative. And constant means unchanging when m equals 0. So, a good clue that you're looking for a linear function in a story problem is when the story describes something that's increasing at a constant rate. How about this? Suppose every year on my birthday, I get a $50 gift from my grandma. And I just take that money and I plunk it in the bank. I never take any out. And let's say she starts this on my, let's say she started on my 3rd birthday. On my 2nd and 1st birthdays, I'm sure she got me something very nice. I forgot what it was. But she decided nothing was better than cash, so she started giving me birthday money on my 3rd birthday, and she's been doing it ever since. Let's express the balance in my bank account as a function of my age. When somebody writes my age x, they mean x should stand for that age. So okay, I'm going to let x equal my age. Never hurts to mention units. Sometimes it's really handy, so I'll do it measured in years. Years. And let's let f of x equal the balance to my account. Let's see. F of 3 is 50. F of 4, on my 4th birthday, I got the second $100, so F of 4 is 100. F of 5 is 150. So what's the pattern? Is it f of x equals 50 times x? If that were the case, then f of 3 would have been 150, and f of 4 would have been, 200. This is 50 times 1, and this is 50 times 2, and this is 50 times 3. So it's 50 times something, all right, but it's not x. You see what it is? It's x minus 2. So f of x isn't 50 times x, it's 50 times x minus 2. Now wait a minute. Does that mean that when x was 1, when I was 1 year old, I had negative $50 in the bank, and when I was 2 years old, I had $0 in the bank? That's correct that I had $0 in the bank when x was 2, but when x is 1, f of 1 should be 0, not according to this formula, 1 minus 2, negative 50. This is tricky. It's a piecewise function. See, f of x is a linear function once x is bigger than or equal to 3. It's 50 times x minus 2 if x is bigger than or equal to 3. But it's 0 if x is less than 3. Good one. Here's another problem that's very common in business. Let's suppose I buy some piece of office equipment, and its value today is $5,000. But its value in 7 years is going to be $100. It's practically worthless. In 7 years I sell it for scrap. And I have to express how much this thing is worth in a given year for tax purposes. Let's use a linear function to do that. Let's express the value of this object, not just as a function, but as a linear function of its age. I'll say t. Measured in years from today. So whenever anybody says something like this, age t, and then they put a symbol right after some noun, they're saying that that symbol should be used for that word. So t should, in your answer, t should be the age of this object measured in years from today. And to say that's a linear function means that, well, among other things, it means that if I graphed t on the horizontal and v on the vertical, the relationship between v and t would be a line. So, is it a line that goes up like this or down like that? It's got to go down like that because the value is decreasing over time. So it looks something like that. T is measured in years from today. So they've given me a point on this line because v is 5,000 at time 0. This is also a point on the line. They're telling me a t and a v that go together. In 7 years from today, the thing will be worth $100. 7 years from today, t will be 7. Maybe that's that point right down there. When t is 7, the value is 100. They want me to find the equation of that line. Not just an equation for it, but the equation, the function whose graph is that line. So let's do what we did before. We'll find the slope of that line, etc. The slope is change in output. So I guess I'm subtracting this minus that. So I must subtract the same direction in the denominator, 0 minus 7. So that's 4,900 divided by negative 7. That's negative 700. So this thing apparently is going down. You know, that negative 700 is the slope of the line. That's how the value is decreasing every 1 unit increase in time. So that negative $700 means that value decreases $700 for each 1 year increase in time. I mean, that's what slope always means. It's the change in output per 1 unit change in input. So what's the line? Well, I could find lots of equations for the line. It's probably easiest to write it in slope-intercept form because I have the y-intercept. Well, I guess I should call it the v-intercept. I've got the v-intercept right there. So it must be that v of t is, there's v, minus 700t. There we go. Notice they didn't want the equation of a line. They wanted the function whose graph is that line. That's why they said express it as a function. And still, I've expressed the value as some function of t. It just happens to be that in this problem they told me this specific kind of function. Since it's the graph of a line, it's easy to check your work. When t is 0, do I get 5,000? Sure, when I stick in t equals 0, I get 5,000 minus 0, so that's right. When t is 7, do I get 100? Sure, that's 5,000 minus 700 times 7, that's 4,900. Bingo. And we're done. When you express value as a linear function of t, they call that straight line depreciation. Depreciation is a measure of how the value is decreasing, and straight line just means they call it straight line depreciation because, well, the value is expressed as a linear function of t.